Okay, in Lab 6, we are going to use what's called a compound conditional evaluation statement. So the idea might be, for example, like this. Let's say that you go to a store and you're hungry. So you go to a market or a restaurant. If you're hungry and you have food, then you can purchase some food to eat. If you're hungry though and you don't have money, then you can't purchase food to eat. Now you might find a different way to barter or let's say get that food, but many times what happens is that multiple things need to be combined together before an outcome can be reached. There are also some times where we can use this or statement. So, for example, you may be hungry and have cash or have a credit card. So in this case, you still have two things which need to work together, but sometimes this or statement gives us multiple different kinds of things that can be combined in a series to allow us to compute that something is either true or false, or that should be, let's say, manipulated or not. So in this case, we're going to use this and we're also going to use this or in order to bring together multiple different evaluations into a single line. And this is exactly what this lab is about. Now, if you remember in Lab 5, we actually handled evaluations on a single line. We said if user input was less than year, or if the user year was greater than or equal to the year, or if the user year was less than or equal to. So these evaluations for us, these statements, don't change for us, but what we're going to do is we're going to chain them together in order to be able to do more processing on a single line and in some ways start to build more complex logic circuits because we have the ability to chain these things together with this syntax called or and with this syntax called and. So I'll go through this lab with you in the next video, but what I would like to do is I'd like to show you this lab as the way it's going to run to give you what is here, this overview. So keep in mind you're going to create a lab and you're going to it's going to be named specific, and I tell you it's going to be and or evaluation. You're going to have the header, you're going to have a print statement for the user. Notice you've got this single line here, this single line here, you've got a block of code right here. So this should start to become looking familiar for you. A block of code separated by a line before and after it, a block of code separated by the next one, and what have you. But what I want you to see in here is this, is that if you notice here, this is our evaluation statement. And I'm evaluating these two values right here against one another using this less than here, but I'm also evaluating these two statements against one another using a different, let's say, operator. So I'm saying if the min is less than user value and also user value is less than or equal to the max, then if this is all true, then this runs. If it's false, if both of these are false, then I can check and see if user value is less than the min alone and go out here, and all other statements then would be this else. Now this is the modern way we do it in Python, and although it may seem initially that it's kind of hard to read, we actually prefer this now over the old school way of doing it. I'm going to have you do it both ways so you get a feel for it. Over here, what we would say is if the min is less than user value, if this is true, and then notice here's our and word, and also user value is less than or equal to the max, so this statement needs to be true, and also this statement needs to be true in order for this statement to run. Now, if I scroll up, if I can, just a tiny bit in here, what I'm hoping you'll see is that this statement right here is exactly the same as this statement right here. All of the print statements and the elif statements are the same, but if you notice in here, I've got the min less than user value, and you can see the min less than user value, but instead of having, let's say, user value sit in the middle here twice, I've consolidated it into a single user value. You can see that single user value right there, and I'm able to eliminate the use of this syntax. So in truth, this gone is exactly this statement right here. And this is the modern way. We simply streamline it in Python. That's what's preferred. But this old school way, which we used to have to do, is still actually very much used in a lot of other programming languages. So we want you to know how to do it both ways. You need to understand the difference between the traditional approach and the Pythonic approach, which means basically doing it in a more streamlined way. So this is the overview on and I'm going to write the code for you coming up in the next video. Or statements, however, and you can notice this is not a long, it's not a long lab, but this or statement we can't do the same way over here. So or is always the traditional way, where we've got two different statements, this statement right here, or this statement right here. So the idea is that if this one's true, then this will run, even if this statement evaluates to false, right? And if this statement is true, and also, or let's say this statement is true, so either one of these could be true, and this will run. But if this statement is false, and also this statement is false, then we end up in this evaluation down here. We say that it's short circuit evaluation because in case this evaluates to be true, we never actually even run this comparison. So we can stop early and we basically say that this is short circuit. If this turns out to be true, there's really no reason for us to even evaluate this over here. Why? Because we already know it's true, and either one of these could be true, and so we just go ahead and not evaluate this. But if we evaluate this side of the expression and it's not true, and then we also evaluate this side of the expression and this is also not true, so then we get down here where we have this else, which is catching all of the other situations. So what I want you to see here, and granted I do give you the code here in this in the lab assignment files, of course I always give you this code, and you can see at the bottom of this file you have all of the code in here. But what I really want you to see is the way that these statements are being evaluated. We have this traditional approach up here where we basically have two separate statements, this statement, and we bring it together with this statement. This is the traditional approach where we simply have two statements on the other side of this and. We also have this Pythonic, or we would say the more modern version, where we can chain together all three of these values, but we chain it together in this being one statement, and then also just reusing that variable, this being the second statement. So we have two different expressions, and because both of them have to be true in order for this statement right here to run, so this has to be true, the min has to be less than user value, and also this has to be true, we basically can just chain them into a single statement. This being the more traditional way, and you have to know the traditional approach because when we get to the or statement, because this is a short circuit evaluation statement, you simply still have to use these two expressions but separate them with this logical or in here. All of this in a lot of ways is what is known as truth tables. And if you've never seen truth tables, that probably means you're not up to the reading on this point. Of course, you could always use, in this case, you could always use ChatGPT or Gemini to look up what a truth table is and to allow it to explain it to you. So I hope that this has been a good introduction to you and to help you understand where we're going with this lab. The next video will write the code directly.